Hello class, welcome to Geometry Lesson 5.5, which is all about inequalities in two triangles. By the end of this lesson, you should be able to compare a pair of sides of two triangles when the remaining pairs of sides are congruent. So let's start out by investigating side lengths in triangles. So if we have a rider that is pedaling a unicycle, how does angle A and the length of B change? What does this suggest about the change in the triangle? So if we look right at this first unicycle, you can see that the pedal is up, which means that this angle is smaller and this side is smaller. Then if we look here, we have our angle A and our side length B got a little longer, and we have the biggest angle A right here, and side length B increased again. So you can see that even though these distances stayed the same, right? The seat post was always the same distance, and that pedal is always the same length. Our third side length changed based on the angle. So that's what we're going to do. We're going to compare multiple triangles that have two congruent sides and compare what happens when you change that angle. So if we compare angle J and side length K for the triangles, which triangle has the longest side K? Go ahead and answer this. Hopefully you realize that the obtuse triangle had the longest length for K, the longest side, because angle J was the longest, right? Let's put a name to this. So that is called the Hinge theorem. So when you have two congruent sides, that is a must. If you don't have two congruent sides, you cannot apply the Hinge theorem. So you absolutely need two congruent sides before you can apply the Hinge theorem. So if two sides of one triangle are congruent to two sides of another triangle, and the included angles, okay, so remember included means the angle between those two sides. So a side angle side situation. Okay, so that angle. And the included angles are not congruent, then the longer third side is opposite the larger included angle. Okay, so the longer third side is going to be on the triangle with the larger angle. So in this case, since we know YWX is greater than CAB, we know that XY would be greater than CB. So if we apply this Hinge theorem, so we are looking at an example of someone working out, and the tension in an exercise band varies proportionally with the stretch distance. Okay, so the amount of tension in that band changes based on how far you pull it. The tension T is described by the function T of x equals Kx, where K is a constant that depends on the elasticity of the band, and X is the stretch distance. I know some of you, when you read word problems, you read a sentence and there's a lot of big words that you don't typically use in everyday language. Don't be discouraged, just break it up, okay? So we know that we have an equation, and we know K is a constant, so we don't even really have to worry about K right now. And then X is the stretch distance, so that's how far the band is being pulled. Which position shown in the figures has a greater tension in the band? So the greater tension is going to be created by the greater the distance, right? The more it's pulled, the more tension there is. So if I took that picture and I just copied down the triangles, so that way they're not on a picture, it's easier to see. Let's compare. So I modeled each figure with a triangle, and if we look, the 50-degree angle, X that's the stretch distance. It didn't get pulled as far, right? You can even see his arms are farther down. But then if his arms are at an 80-degree angle, you can see that the band has stretched farther than when it had with the 50-degree angle. So you can see which position shown in the figures has a greater tension in the band. Well, the farther you pull it, the more tension there is. So that means that 80-degree angle has greater tension than the 50-degree angle. Okay, so then let's talk about the converse of the Hinge theorem. Hopefully by now you've picked up that the converse just means the opposite, right? So before we talked about how if we were given an angle is bigger than an angle, then we can say something about the sides. The converse is if we are given the sides, then we can say something about the angle. So if EF, if I know that this side is greater than this side, I know that angle D has to be greater than angle T. And remember, just like with the regular Hinge theorem, you have to have two sides that are congruent on both triangles. And then it's talking about the angle between those two sides. All right, example 3, apply the converse of the Hinge theorem. What are the possible values of x? So if I look at this, first I want to point out the fact that some of you are going to look and say, oh, this is 36. That means that this is also 36 because of vertical angles. This picture is not the best. We're going to treat this, it's hard to see, but this is not a straight line. Like, these angles change, and I know my outlining that did not make it very clear. But the way the book is treating this is that this is not a straight line. It has a curve to it. That means that it can't be vertical angles. Vertical angles are, that didn't help. Vertical angles are, this smartboard does not let me draw straight lines, are when you have two completely straight lines, okay? This is just a triangle. This is another triangle. And then this is a third triangle. So none of those are straight lines there. All right, so if I want to figure out the possible values of x, well, if I want to figure out the possible values of x, I'm going to have to compare that to some other angles. So if I look, there are my two sides. Here are my two sides. So I know that I'm going to be comparing angle DEC to angle, let's see, FEG. I know that FEG is 36, and I know DEC is 2x minus 4, but I have to figure out which one is bigger than the other. Well, 2x minus 4 is opposite of 18, right? The side that it's opposite from is 18. And 36, this one right here, is opposite the side that's 14. So that means that 36 degrees is less than my other angle. So I can say, I can solve this now. I can add 4 to both sides, and I have 2x is greater than 40. And divide by 2 of x is greater than 20. So that's one of my answers, that x is going to have to be greater than 20. But I have a whole nother triangle here. So let's compare to this other one. So here are my congruent sides. My included angle is 60. So again, I can do angle DEC, so 2x minus 4, is going to be something in relation to BCA. And BCA is 60. Now that 60 degrees is opposite 21. Since 21 is bigger than my side length 18, I know that 60 degrees has to be larger. And if I solve, I can have 2x is less than 64, or x is less than 32. Now that I have those two, I'm going to write a single inequality, just like I did in the last section. X is greater than 20 and less than 32. So those are my possible values for x. I want you to try to solve for the possible values of x in this diagram. One thing that's a little different is since we're only comparing it to one angle, that means that we would only get one value for x. But I want you to realize that we can't have an angle that's 0 degrees. So you're going to actually solve twice. You're going to compare to angle 54, and then you're also going to compare to a 0. It has to be greater than 0. Okay? So why don't you go ahead and try that, and then I'll write out a solution for you guys to look at. Good luck. Hopefully you set 4x minus 18 to be not equal to 54, but less than 54, because 54 was opposite a side length of 12, and 4x minus 18 was opposite a side length of 10. So since 12 is bigger than 10, I know that angle 54 has to be bigger than my 4x minus 18. When I solve that, I end up with x is less than 18. And then, just like I said, I know that this angle also has to be greater than 0. So I'm going to say that 4x minus 18 is greater than 0 and solve, and I get x is greater than 4.5. And if I write my inequality as a single inequality, I have 4.5 is less than x is less than 18. And our last thing, concept summary, inequalities in two triangles. You have your Hinge theorem and your converse of your Hinge theorem. If you have any questions at all on this lesson, please be sure to ask for some help, and I'd be happy to assist you. Have a great day.